Welcome to AMS Talks. I'm your special guest host, Nadia Aboud, and today I have the pleasure of sitting down with Dr. Vladimir Dortstev, Senior Product Manager at AMS, for an in-depth discussion on innovation in Cr6 compliance. Vlad, thank you for joining me today. It's wonderful to see you.
Thanks, Nadia, for having me.
I always love when we sit down because I learn something new. And I was really excited to have some of your time because Cr6 compliance is such a pressing issue at the moment. With California's new regulation set at 10 parts per billion, hundreds of water systems effectively are racing against the clock to meet the regulation. They are evaluating and demonstrating treatment technologies so they can put together their compliance plans. And you, Vlad, with your PhDs in chemistry and chemical engineering, and then being the author and co-author of several patents around the in situ generation of specialty reagents, that's why I'm meeting with you today, because one of your innovations is gaining traction as a game changer when it comes to Cr6 treatment. But with any new approach, there always raises important questions. So before we dive into the technology, I would love if you could share with some of our viewers, let's just go back to the basics. With all the treatment options that are on the table for a utility, what are the best available technologies for Cr6?
So right now, California identifies three best available technologies for hexavalent chromium removal. Those are ion exchange, reverse osmosis, and reduction coagulation filtration, or RCF. Most RCF technologies or approaches based on ferrous reducer reagent, which converts chromium-6 into non-toxic chromium-3. However, challenge with this approach is in slow kinetics of this conversion reaction and necessity to oxidize residual of ferrous reagent into filterable ferric after chromium-6 conversion. And to these limitations make this approach difficult in the implementation in the field. On the contrary, Safeguard H2O is RCF-based approach which utilizes electrolytic stannous reagent, which we generate on demand at site, which is already a big advantage by itself. It eliminates reagent delivery and storage at site. We produce it in small quantities, and we consume reagent on demand per schedule of treatment, and it offers multiple benefits. And most importantly, stannous reagent is much more powerful reducer, which simplifies treatment chemistry and obviously entire system design.
So, how do these treatment performance differences translate to the environmental impact of these technologies? Like, what does the environmental footprint look like for each?
This is a very important question. Ion exchange, for example, is highly problematic because of generation of very high volume of potentially toxic byproducts. For instance, in some ion exchange systems, up to 5,000 gallons of problematic regenerant produced per every kilogram of hexavalent chromium removed. In RCF, it may be also problematic in volumes of sludge produced because doses of ferrous is much higher than stannous. In a situation with electrolytic stannous, we produce very low volumes of non-toxic byproducts, somewhat less than 5 dry gallons of sludge per 1 kilogram of chromium removed. And obviously, disposal problems for our approach are minimal. And we also envision possibility to reuse our sludge for another remediation processes where sludge can be literally recycled and no disposal required.
Oh my gosh, Safeguard H2O is packed with a lot of benefits, Vlad, from the treatment, approach to the environmental and sustainability. All of that has got to probably translate into cost, and cost with any regulation is, that big elephant in the room. So you there are a lot of city councils right now thinking about the cost of compliance and how can they minimize that as they move forward to meet this regulation. So how does Safeguard H2O stack up financially when you look at the more traditional approaches to Cr6 removal?
You're absolutely right, Nadia. Cost is eventually final criteria for decision making. And in this aspect, Safeguard H2O offers multiple benefits. First is overall lifetime cost of our treatment is up to 40% lower than any alternative in the market, either ion exchange or RCOF with ferrous reagent. And these savings mostly come from two benefits we already discussed. Is very effective reducing power of electrolytic stannous and very straightforward and simple design of our system relatively to alternatives. In state of California, in their own reviews, they found that RCF is the most cost-effective way to treat hexavalent chromiums to limits below 10 ppb. We should mention here that our approach is utilizing online monitoring of treated effluent, which allows not only to ensure compliance, but also optimize treatment system to reduce use of essential chemicals, which obviously reduces operational costs, sludge amounts, and manpower.
Vlad, for some of these water systems that are going to start evaluating technologies, you touched on some of the criteria around performance and reliability. That's really critical. So, what have you seen in terms of real world validation, full scale demonstration for the Safeguard H2O and how it stacks up?
Thanks for this question. We hear this question quite often. What makes our approach unique, like I mentioned, it's two key factors. Number one is effectiveness of electrolytic stannous as a reagent, which is obviously one of the key factors. It allows to treat chromium-6 very tightly and make fine-tuning of reagent dose to the level where we control chromium-6 in the effluent within range of 1 or 2 ppbs very tightly using our online monitoring approach. And this allows for multiple benefits. First is, of course, system performance and reliability, which is highly critical for unattended systems, which can be operated and monitored remotely. Secondly, we offer opportunity to treat chromium-6 to non-detect reliably and continuously, which no other system can achieve. It allows for obviously much better effluent quality, very close to public goal of chromium-6 residuals below 1 ppb, and obviously proof for future MCL reduction.
Vlad, it's my understanding that the first full-scale system of this technology has been delivered to a site in Northern California and will be coming online shortly. So I'm sure that people interested water systems will be eager to learn more as that comes online. And speaking about learning more and thinking about working with Safeguard H2O, what does that process look like? If a water system is ready to, they've heard the benefits of the treatment approach, the minimized environmental impact, if they're ready to demonstrate, walk us through that process.
It's very easy to demonstrate our technology at site for multiple reasons. Number one is we have a rapidly deployable demonstration system, which is obviously mobile and can be deployed within hours in the field. It takes somewhat below 2, 3 hours to hook it up to utilities, water flow, water source, and electricity. And then within next 2, 3 hours, it's fully stabilized and monitored and can be monitored remotely from any location on Earth. The system comes, uh, like we mentioned, with self-contained 20-foot trailer, which includes 5 main components. It's a Stanus reagent generator, obviously, and control module, electrolytic reagent generator, contactor for conversion chromium-6 to chromium-3, sand or media filter, and metal guard, which provides monitoring of chromium-6 residuals in the effluent.
Well, that's amazing, Vlad, especially with all these utilities feeling, this time crunch that to know that getting the technology there to demonstrate it is not a limitation. It's, as you said, rapidly deployable. So um, I know with October 26th coming up, we have the larger water systems and their first, compliance states. Everyone's thinking about this. How are they going to meet it? What would be your final message to water managers across California?
Well, it's important, challenging times for utilities, and the decision which will be made today will have implications for long time period downstream. So, what we definitely would recommend to utilities is to look into alternatives and consider our approach because it actually very selective approach and absolutely unrelated to treated water metrics, which means we proved multiple times in the field that our approach works with most challenging water matrices and constituents. We offer very competitive, lowest lifetime cost now in the market. And as a technology provider, we recommend to potential users of our technology to learn about us and get in touch.
That sounds great, Vlad. I know you'll make yourself available should people have questions, but thank you for sitting down with me today, taking the time to share your insights on the innovations around Cr6 treatment and compliance. And for more information, our viewers, you can visit ams-h2o.com.
Thank you, Nani.
Thank you.